This question asks which force creates the greatest biomechanical difference between unicortical and bicortical screws. The two screws are shown in the image at the bottom of the page. The bicortical screw on the left extends all the way through the near and far cortex of the bone. In contrast, the unicortical screw is shorter in length and only goes through the near cortex of the bone. The first three forces are shown in the image at the bottom. Compression is a pushing force, distraction is a tension force, and torsion is a twisting force. The blue lines in the bone represent the two different types of screws. Torsion is the correct answer for this question because the bicortical screw is longer and has more contact with the bone. When a bone is twisted, the bicortical screw creates more resistance to the motion than the unicortical screw. Compression and distraction do not create a large biomechanical difference in the screws because the applied forces are not in line with the screw. The forces are acting perpendicular to the screws and do not have much effect on the behavior of the screws. Forces can also be applied to the plate that is supporting the screw. In the pictures on the left, a force is being applied to the side of the plate to bend it. You can also see a top view of this force at the bottom of the page. This force does not really depend on the length of the screws because it ends up being distributed around the screw. Therefore, this force does not create much difference in the biomechanics. In the picture on the right, the force is being applied perpendicular to the plate or to the top of the plate. With this force, the plate will be bent downwards along the sides of the screw. Once again, the length of the screw does not create a large biomechanical difference with this force. In conclusion, the greatest biomechanical difference between unicortical and bicortical screws is created when a torsion force is applied.